for a longer period of time. Having said that, let's move to our first board where we will be talking about how VXLAN increases the number of VLANs. But before doing that, we need to understand why there is a limitation of 4096 VLANs in normal switching or spanning tree areas, spanning tree time or trunk time, you can say, or normal VLAN or normal data centers, right? So if you see here, we have a picture here where which we can say that every link here is trunk. And you all know if all these links are trunk or layer 2, spanning tree will be blocking some of them. You all know about it, right? Why spanning tree blocks them? Because it wants to avoid loop. As simple as that, right? And you all know this, that if this host wants to communicate with this host, right? Maybe if this host know the IP address of the another host, maybe this host is B, this is A, then what is going to happen? If A knows the IP address of host B, it should also know the MAC address, and that is why it is going to do the ARP. And if this is an ARP message, it will reach to switch 3. And what switch 3 will be doing with this ARP message? Switch 3 will take this ARP message, and because this ARP message is the broadcast message, it is going to forward it on all the interfaces except the one from where it was received, right? And this is how switch behaves, or switch forwards the broadcast messages, you all know. And of course, because this link is down by the STP or the blocked by the STP, you are not going to send the ARP message here. But before putting this ARP message on this wire, you all know that switch 3 will be putting a message or a number here, and this number is exactly the VLAN from which this message was received, and that is why you are going to put VLAN number 10 here. As simple as that, right? And this tag, this number is actually known as .1Q, and if we see the same thing in layer 2 header, you can see there is an ICMP message. If I presume that instead of R, this is an ICMP message, then the source IP and destination IP is going to be there. Then the type field which specifies what is inside, it is going to say the inside message is going to be IP. And if this message is ARP, it will be say the inside message will be ARP, and that is the function of type, right? And then we have .1Q field, and .1Q field has 12-bit VLAN ID. And you all know from 12 bits, we can have 2 to the power 12 combination, which will be 4096. And that is why we can have only these many VLANs. Because you all know that if we have a VLAN 10 here, right? And if we have a VLAN 10 here, then this VLAN is extended across multiple switches, and the traffic for this VLAN will be flowing over this trunk. The ARP will be reaching to switch 1, then switch 1 will be forwarding it to here, everywhere, except on the port from where it is received. And eventually this message will be coming to this switch 6. Switch 6 will be forwarding it to BBB, and from there the ARP reply will come. And ARP reply is going to be unicast. You all know about it. The whole sole point is when you put your ARP message or any message on this trunk interface, you have to specify the number. As simple as that. Now my question to you guys is, suppose there are 2 more servers here, server C, server D. These are also in the VLAN 10, right? And maybe the IP address or the MAC address is CCC, and the MAC address for this guy is DDD. IP, you can presume anything. If this guy wants to communicate to this guy, again, it is going to send the ARP message, and this ARP message will be received on switch 3 also, to switch 5 also, to switch 6 also, because this is the broadcast message, you all know. And because we have trunk interfaces, we can put just VLAN 10 and forward it. And you can see that the VLAN 10 is now present on all the switches, 3, 4, 5, 6. You all know that right now. Interesting. But here is the question. Can you do something like this, that the ARP message from red color servers can only stay in switch 4 and switch 5? And you must be wondering, Mr. Vishnu, that is why we have VLAN 4. If you want switch 4 and switch 5 or the host C and host D messages should be reachable to only switch 4 and switch 5, then put them in some other VLAN, maybe VLAN number 20. But can we do something like this, that the thread servers, whatever you are seeing here, are only in VLAN 10, but their ARP message doesn't reach to switch C and switch 6 and switch 3? And you will be thinking, and you must be thinking that, Vishnu, what happened to you? You are good in switching, right? And I totally agree with you that we cannot do that. And this is the definition of broadcast domain, right? If we have layer 2 trunks here everywhere, my broadcast is going to be everywhere in my entire network. Wherever I have this layer 2 domain, I will be forwarding the broadcast there. And that is the definition of broadcast domain of VLAN. It means that doesn't matter if the broadcast is coming from the C, D, A, or B, it is going to reach all the switches. And that is my switched network or layer 2 network. But the only condition is, right, that whenever you put the ARP message, just put the .1q header on top of it. And that is the only requirement, right? So that when this packet reaches to the destination or the destination switch, the destination switch knows where to forward this message, in which VLAN to forward this message, right? Guys, the overall intention is to increase this VLAN count from 4096 to 16 millions, right? This is what we want to understand. I just let you know that why we are having 4096 VLANs in our current switched environment. Again, repeating, if you are sending the message on this trunk, you need to put the .1q header, and the .1q header is of 12-bit, and that is why you cannot have more than 4096 VLAN. Otherwise, suppose you have a VLAN which you are specifying with the number 5212, right? This is your VLAN. How you are going to send the ARP message from this VLAN if you do not have the proper tag value for it, right? From 12 bits, you can specify from 0 to 4000 or 1 to 4096, but 5212 is the range which is more than 4096, and that is the reason we have only 4096. Now, let's increase it. But the question is, we want to increase it in VXLAN environment, right? How it is going to happen? But before understanding that, we need to once again understand a term which is known as VNI. So I am officially introducing this term VNI, which is Virtual Network Identifier. What is the meaning? The meaning is very, very simple, guys. Suppose host A is here, host B is here, and now I'm talking about VXLAN. Now I'm talking about that there is no trunk link. All these links are layer 3, so they both can work together. We have been discussing about it, right? If that is the case, what is going to happen? We have server A here or host A here. IP address is 10.10.10.10. MAC address is AAA, part of VLAN 10. And what I'm doing here is on switch 3, I am saying that Mr. Switch 3, your VLAN 10 is mapped to another number, and this number is suppose 5010. Very, very interesting, right? Now, what is going to happen? Of course, if these are the layer 3 interfaces, you cannot put .1q tag on it, because .1q tag you can put on the trunk interfaces. And these are my layer 3 interfaces, pure layer 3. You are going to see IP address here, you are going to see IP address here, and these interfaces endpoint are taking decision on the basis of destination IP address, not on the basis of MAC address. And that is why these are layer 3 interfaces, as simple as that, right? So suppose this guy wants to ping 10.10.10.20, which is after switch 6. Suppose the IP address I have configured on switch 6, maybe a loopback interface is 6.6.6.6. And the IP address I have configured on switch 3 is 3.3.3.3. As simple as that, right? When this message then, and I'm presuming that I know the MAC address of BBB, right? Or MAC address of 10.10.10.20. How? I'll let you know. But I'm presuming here right now that I know the MAC address of host B. If that is the case, what is going to happen? This packet will be formed. The host will create the ICMP letter, and source of this letter is going to be 10.10. Source IP, destination IP is going to be 10.20. Source MAC is going to be A.A.A and B.B.B is a destination MAC. And this is my layer 2 message, which will be coming out from host A and will be reaching to switch 3. And now switch 3, what switch 3 does? Switch 3 sees that this message is coming from VLAN number 10. Interesting. But some intelligent guy is saying that your VLAN number 10 is equivalent to 5010. And by the way, this is the VNI or virtual network identifier. This number is known as VNI, which you can put in this VXLAN header as a number. And this number is going to be 5010. Interesting, right? And again, the remaining terms, you know, the UDP message, you know, it is for the load sharing, 5.5.5.5. This is 6.6.6. From where I'm getting this information? It is very, very interesting. I will get to know this information from this intelligent guy. This intelligent guy will say that the VNI 5010 is also available at 6.6.6.6. Very, very interesting. How does it know? Because it is seeing your network from the sky, maybe. And I will be letting you know that this intelligent guy will become the BGP EVPN someday. And on switch 6 also, which is having this VLAN 10, what I am informing switch 6 that Mr. Switch 6, your VLAN 10 is mapped to 5010. See this number. This number is same. Really interesting, right? And that is how I come to know this intelligent guy is saying that you need to send this message to 6.6.6.6 if you want to send it, because this guy is also having this VNI 5010. When this message reaches here, what is going to happen? This message will be reached with 6.6.6.6. This will come to know that the inside message is the VXLAN message, and the VXLAN message will say, okay, there is a VNI field 5010. Through this VNI field, switch 6 comes to know that it needs to send this inner L2 message inside the VLAN 10. Why? Because 5010 is mapped to VLAN 10. As simple as that. Really, really interesting. If that is the case, you all know that there will be a tunnel from 3.3.3.3 to 6.6.6.6, and I can write on top of this tunnel that this tunnel VNI information is 5010. So if you understand this message, you understand this tunnel. You all know about it. But you must be thinking that, Mr. Vishnu, you have introduced only one word. Apart from that, we have seen all this information in the previous classes. Believe me, the aim is still to understand why and how VXLAN increases the number of VLANs. Believe me, I'm coming to that point only. Now, just try to understand. We have switch 4 and switch 5 here, right? And now switch 4 has host C, the MAC address is CCC, and this one is DDD, right? These are again in VLAN number 10. Very, very interesting. VLAN 10 and VLAN 10. Now I am saying that when the message comes from this guy, maybe R for the unicast message, what I am informing switch 4 is that your VLAN 10 is mapped to not 5010. Suppose, right? It is mapped to 6010. Very, very interesting. And the switch 5 says that your VLAN 10 is mapped to 6010. This intelligent guy is seeing all this information, and this is saying 6010 is present on 5.5.5.5 or switch 5. Maybe the one loopback is here, which is 5.5.5.5. One loopback is here, which is 4.4.4.4. Now, if I may ask you, if this guy sends an ARP message or maybe the unicast message, what is going to happen with that? Now this VXLAN VNI value will be replaced from 5010 to 6010, right? And once it is reached here, this guy will ask the control plane or this intelligent guy where I need to send it. The intelligent guy will say that 6010 is present at 5.5.5.5. So you need to send it there. Interesting. In this case, the destination is going to be 5.5.5.5 instead of 6.6, and the source will become 4.4.4.4. If that is the case, the V external which will be forming, it is going to be this one, and I can write the number on top of it, 6010. Very, very interesting. Just try to understand. Now we have two different links, right? Although the VLANs are same, VLAN 10, VLAN 10, VLAN 10, and VLAN 10, but this doesn't have any significance. All these numbers are locally significant. Why? Although these two VLANs are same, but their ARP message will be, suppose if CCC sends an ARP message, it will be coming only here to switch 5, right? Because VLAN, it is not identified by the VLAN 10, it is identified by the 6010. If this host A sends an ARP message, it will never come to switch 4 or switch 5 because we do not have 5010 VNI there. When we ask this intelligent guy, 5010 VNI is present at 6.6.6.6, and that is why the green tunnel or the green link, right? It means that the VLAN numbers doesn't matters at all. Believe me, if I change this VLAN 10 to VLAN 500, suppose, and I keep the addressing same, right? I am on switch 6 and I have changed the VLAN 10 to VLAN 500, and I mentioned that now VLAN 500 is the same VNI. Believe me, there is not a single change in the communication, right? The communication will be through. Why? This guy will be sending the same message here. When the message is decapsulated, it will be coming with the VXLAN ID or VN ID of 5010. 5010 is now mapped to VLAN 500, and the ARP message or the unicast message will come into this VLAN, as simple as that. So we can have the communication between VLAN 10 and VLAN 500 if the VNI is same. Or even these two VLANs 10 and VLAN 10 with so this, if I say this VLAN and this VLAN, right? Previously, these were VLAN 10. These are different than these. Why? Because now the identification factor is 5010. Previously, these links were layer 2 links, guys. We were sending trunk information or .1q information, which can be only 2 to the power 12, which is 4096. But now we can send this information as VNI. And now this information can be represented with 2 to the power 24, which is going to be 16 million something. Really, really interesting. But now you can ask me a question. Mr. Vishnu, you are good. You are right, right? That now the VLAN can be identified with this, and these are the local number, but still my switch is only having 4096 VLAN, right? Here in my previous network topology, still I can have only 4096 VLAN. See, if I have only 4096 VLAN, you can map it to any, you can start from any number. For example, you can map 1 to 5001, 2 to 5002, and similarly 4096 with some big number, but still my VLANs are going to be same, right? This question should be in your mind. But believe me, with this board, if you have the proper understanding of this board, then in the next board, I will increase the VLAN count from 4096 to 16 million. Believe me. But to understand this, you need to have understanding of starting two boards, which I've explained, right? Mr. Supreet, let me complete the next board and I will come to you if you have any doubt after that. Okay. So here you go. I am going to the next board and just try to pay close attention here, right? Because this is a practical scenario and where you are going to learn that why or how this number is increased, right? Consider we have this old spanning tree model, or basically we have all trunk interfaces here, right? And this is the data center of Sports India Private Limited, and they are making a huge data center. Their business is doing well. And Mr. Rahul is their guru person, network engineer. And now Mr. Rahul, what Mr. Rahul is doing? He's saying, okay, this complete network belongs to me and I am owner of the all 4096 VLANs. And that is why he has created many VLANs over switch 3 and switch 4. Maybe I cannot show you the 40 switches, so I am showing only 2 switches which are under control of Mr. Rahul, right? Maybe these could be number 10, 20, 30, who knows, right? It depends on the how much Sports India network is big. Now, Rahul has created the world-class data center where he is connecting all of his servers right here. Now, many people who are friend of Sports India or the partner of Sports India, they want their own servers to placed here, right, in the same data center. It means that Mr. Rahul or the Sports India is going to charge them that they are using your infrastructure of switches and routers, right? So Mr. Rahul is saying, okay, we can accommodate other users also. So here is customer A who come and he wants to connect some of his server in the same data center, right? So what Mr. Rahul is saying, okay, that is fine. You can connect your server. And then this customer A says, if that is the case, I do need some VLANs. And here is the problem. Mr. Rahul is saying that previously I was whole sole owner of 4096 VLANs, right? If I want to give some of the VLANs to this guy, then of course I need to put some of my VLANs and then give away some of my VLANs, right? For example, he can put 2096 VLAN here. He can have those and give 2000 VLANs to this customer A. Very, very interesting. Customer is happy. He is having 2000 VLANs. So Mr. Rahul has specifically informed him that from 1 to 2096 I will be using, and you can use from 2097 to 4096 VLANs, right? These VLANs are for me, these VLANs are for you. Then Mr. Customer A is pretty happy with that. That is okay. And he is using these 2000 VLANs. But Mr. Rahul has strictly informed this customer that, see boss, suppose I am using VLAN 100, you cannot use VLAN 100, right? Because I do not want my VLAN 100 traffic to go into your network, and even customer doesn't want that, right? Right? If Mr. Rahul is using VLAN 100 here, and accidentally this customer or this customer A also started using VLAN 100, if Mr. Rahul's machine send an ARP message, it will be here, right? And it will come to switch 5 also. Very, very interesting. By the way, this port is down because of STP, but it will again come to switch 5. And Mr. Rahul's traffic reaches to customer A traffic, which is not acceptable at all, right? But here is the problem of this data center. This data center can have only 4096 VLANs across, not per switch, across. If VLAN 10 is used by Mr. Rahul, nobody should use that VLAN, right? Now, here is the problem. Mr. Rahul business is growing, and now there is another partner of the customer who wants, and the customer name is B, who want to connect some of its servers now to Mr. Rahul's data center. And believe me, this is actually what is happening in current cloud data centers. There are so many customers who want to put their workload, who want to put their servers into these data centers, right? And if that is the case, they need VLANs, right? And now Mr. Rahul is saying that I am using 2096 VLAN, customer A is using 2000 VLANs. I cannot give you any VLAN. Maybe Mr. Rahul can say, Mr. Customer A, you can use 1000 VLANs and the remaining 1000 VLANs you can give to customer B, right? But here is my problem. Suppose in this data center, 1000 customers come and everybody is asking for 10 VLANs. It means that you need 10,000 VLANs, which is not a number which you can provide. You can have only 4096 across this data center, right? And that is the main problem. That is one of the problem, right? With old data centers, they are not scalable. They are not scalable with respect to current needs, because right now in today's environment, a particular data center can be used by many customers. If that is the case, 4096 VLANs are not enough, right? Who thought at that point of time when they were building .1q header that in coming time 2 to the power 12 means 4096 VLANs are going to be less? But we are seeing right here, right now, right? 4096 VLANs are not enough. Now let's see. And remember the knowledge of previous two boards. If you know them, you can solve this problem. Believe me. Now Mr. Rahul is developing another data center, and now the technology he's using is VXLAN. And you understand the concept of VNI now. VNI is actually 24-bit field. It means that you can create 2 to the power 24 means 16 millions number, right? Just have this thing in mind and have the knowledge of previous two boards in your mind. Mr. Rahul is developing the network or data center on the basis of VXLAN. So all these interfaces are L3 now, right? All these interfaces are L3, everything is L3. So every interface can be used. Now, Mr. Rahul is using the starting two switches of this data center, and they are saying 4096 is the number I am using. He's saying I am mapping my VLAN number 1 to VNI 1, VLAN 2 to VNI 2, and similarly VLAN 4096 to VNI 4096. It means that out of 16 million, only 4096 VNIs are gone, right? If Mr. Rahul creates VLAN 10 here, 20 here, 30 here, right? If he creates 10, 20, 30 here, definitely he needs to map it according to this scheme. And that is the case, then you are going to see different tunnels, VLAN 10, maybe VLAN 20, maybe VLAN 30, right? Maybe with some other color, maybe yellow, right? And these tunnels can be identified by the VNI 10, 20, 30. Mr. Rahul has the luxury to give VLAN 1 to 1 VNI, 2 to 2 VNI. But still, believe me, in terms of VNI, we have 16 millions number, out of which 4096 is used by Mr. Rahul. Now, as he is creating the big scalable data center, now the customer A came. And customer A is saying, I would like to use your data center and I need many VLANs. Mr. Rahul is saying, okay, use 4096 VLAN, any number you can use. You can create any number. But for them, the VNI should be different. He's saying to customer A that customer A, if you are using VLAN number 1, then the VNI for this should be maybe 5001. For VLAN 2, it is going to be 5002. For VLAN 3, it is going to be 5003, and so on. We do not have these number shortage. Just wait a minute, guys. So you can see right here that we do not have shortage of these numbers. These are 14 millions, right? And now here is the question. How this VLAN 1 is different than with this VLAN 1? These are absolutely different. Suppose this guy, the customer is using these two switches. He is creating a VLAN 1 here or 10 here, VLAN 20 here, VLAN 30 here, again VLAN 10, 20 and 30 here, right? Now, when he creates or when he communicates with each other, then we can have VLAN 10, VLAN 20 and VLAN 30. But here is the interesting thing. The interesting thing will be that this tunnel is totally different than this. Why? Because this is identified by the number 5001. This is identified by the number 5002 or maybe 5010, 20, 5030. As simple as that. So if somebody here wants to communicate to somebody here in the same VLAN, right? They will send their ARP message. This ARP message will be inside this VLAN 10 and this VLAN 10 only and not here. And the reason is because this is totally different. In case of layer 2 environment, we cannot do that because we have same 4096 VLANs which can go over these trunk interfaces. But here we are not using that number at all. We are identifying our VLANs on the basis of totally different number, right? This number of VLANs is not significant now. This is totally local to the switch. And we can create, see here 4096, for this customer 4096, and for many customer we can create VLAN as many as this number 24 is. Suppose there is another customer comes here and he is working on this. Mr. Rahul can say you can also use 2000 VLANs, but or maybe 4000 VLANs, whatever, right? But the number should be from, if you are using VLAN number 1, your numbering should be 6001. VLAN number 2, 6002, and so on. This is how we are increasing the VLANs. Actually, the VLANs are going to be 4096 on the switch, but the most important number in case of layer 2 was 2 to the power 12, which is the .1q tag. And here the tag or the virtual network identifier is 2 to the power 24, which is 60 million. That is why our VLANs are going up. Very, very interesting. And now Mr. Supreet has question. Supreet ji, please do ask your question. Go ahead.
Vishnu, can you just go to the board above previous one?
Okay.
Yeah, now I have a question. So let's say, for example, VNI is just a mapping of one specific number to the traditional VNI. Is that right?
Mm-hmm.
Okay. Now, so this VNI number should be unique over the VXLAN fabric, or it can be similar. Now, let's say, for example, when I'm having a communication from switch 3 to switch 5, that is from server A, which has a MAC address of AAA, to server B, which is the MAC address of BBB.
And you want, this is your own server in the VLAN 10. You want this server to be inside your VLAN 10, right?
Right.
Yeah.
And I have mapped VNI number 510 to VLAN 10. But now let's, for example, VLAN 10 is mapped to VNI 5010.
Okay.
But now let's say, for example, I have one more server which is in VLAN 20. And it has the same VNI conflict 5010. Will still that work?
Yes, if this subnet is same, then it is going to work. And it's a very, very interesting question. That is what I said here, Mr. Supreet. If you change this number from VLAN 10 to VLAN 500 also, or maybe VLAN 20 also, but if you have the same VNI, these are going to communicate. The packet will be coming here for sure.
Okay. And when you say the VNI number is locally significant to a
not
switch,
VNI, not VNI. VLAN number is locally significant.
Okay. That was the reason, because when we say locally, that's the reason I was pretty confused, because if VNI was locally significant, how the...
No. VNI is, if I have said that during this class, it's means one of the biggest mistake I have done. The VLAN is the locally significant number in the case of VXLAN. In this environment here, the VLAN is not locally, sorry, this is the VXLAN environment. If I go here, do you agree, Mr. Supreet, that VLAN here is not locally significant, right? VLAN number.
Yes. It goes because of .1q header.
Yes, you are right. But here, the VLAN number becomes a locally significant because of the VNI. You get it?
Because VNI gets transferred in the packet rather than VLAN goes into the packet.
Indeed. Okay. I think everybody should understand now that still VLANs are 4096, but we are talking about layer 3 here. We are talking about many customers here, and that is why we are identifying the VLAN. Previously, we used to identify with these numbers. Now we are identifying the VLAN using this VNI field, and that is how I'm saying 4096 is increased to 16 million. If anybody has the slightest of doubt with this, please raise your hand. Anybody? Okay, at least tell me that you get it. Please raise your hand if somebody has any issue. I think Supreet. Prakashji, you have raised hand. Please go ahead, Mr. Prakash.
So per customer, we can have only this 4096 VLANs only.
Believe me, for one customer, it is too much, man. But if he still wants more than that, then he can have the another 2 switches, and you can use the same from this 4096 to he can increase it, right?
Okay.
Yeah, but for one customer, 4096 is too much. Okay. But the problem is of 1 lakh customer if they comes to you, right? If 1 lakh customer is coming and everybody is asking 10 VLAN, then we have 10 lakhs VLANs requirement. And still we have 16 millions. 1 million is equal to 10 lakhs. So it's a biggest data center we can have. This number is more than enough in today's world. But you never know. Upcoming scenario, what is going to happen? Maybe this number is going to be small, maybe sometime.